All right, we're going to do the first free response problem from review day number 6. We were given a graph and told that this is g, and then there's another function f that is equal to 3x plus the integral of g from 0 to x. And first thing we're asked to do is find out what f of 7 is and what f prime of 7 is. So we'll start with f of 7. If I put 7 into this function here, I'm going to get 3 times 7, 21, plus the integral from 0 to 7 of g. So that integral from 0 to 7 of g is just the area from 0 to 7. So that's going to be this half circle, which has a radius of 3. So the full area of the circle would be 9 pi. Half of it would be 9 pi over 2. And it is below the x-axis. So it's going to be a negative 9 pi over 2. And then we have this area right here from 6 to 7, which is just this rectangle. So it's got an area of 3. So you can leave it like this or make it 24 minus 9 pi over 2. Either way, that's going to get you 1 point for finding f of 7. Right? And as far as f prime goes, then we're going to take the derivative of f, which is the derivative of 3x, 3, plus the derivative of the integral, which cancels. Drop that in. It's going to be just g of x. So f prime 7 is equal to 3 plus g of 7, and g of 7 was 3. So 3 plus 3 gives us 6, and that would have gotten you a point. Right, so not too bad to start with there. B says find the value on the closed interval where f attains its maximum value. So to get the maximum value, we need to look for critical points, right? And a critical point is anywhere that the derivative f prime of x equals 0. So we're going to take f prime of x, what we found before, 3 plus g of x, set it equal to 0. So that's when g of x equals negative 3. So the only time that g of x equals negative 3 is right here at x equals 3. Okay? Now here's the deal, though, is that before that time, g of x is above it, which means that f prime would be positive going into 3, and then it's positive afterwards. So this is a little sneaky because at first you might think the maximum might be here at 0 or something, but that's just assuming that this only is the derivative. But technically, by definition, the derivative has this plus 3. So imagine this whole thing added by 3, moved up 3 spaces. So the whole thing would be above the x-axis then. Therefore, what we can say on this one is f prime is always greater than 0 for negative 4 to 3. Therefore, the maximum occurs at x equals 3, at the end of the interval. All right? And if you had said that, you get 2 points. I'm assuming 1 point for something describing this here, and then 1 point for talking about how the maximum was at 3. C says find each of these limits, and we're supposed to find the limit of g prime as we approach 0 from the left, the limit of g prime as we approach 0 from the right. So in other words, what they want you to do is go to the graph and say, well, what's the slope, what's the derivative coming from the left, and what's the derivative coming from the right? So from the left, that's easy enough. It's just the slope of this line. So we would say that the limit as x approaches 0 from the left of g prime of x is equal to negative 1/2. That's the slope of that line going down. That would be worth 1 point. Okay? And then from the right side, a little bit different issue. We have this circle, and it's approaching kind of this vertical tangent. And a vertical tangent, it has an undefined slope. So because it's an undefined slope, we would say the limit coming from the right side does not exist. And that would get us a point there. All right, our last one asked us to find the limit of this here. And so what we're going to do is plug this in. We're going to have f of negative 2 plus 7 over e to the negative 2, or 3 times negative 2, so negative 6 plus 6, that's 0, minus 1. Now, f of negative 2, if we put negative 2 in, is going to give us negative 6 plus the area from 0 to negative 2. From 0 to negative 2, that's this triangle. All right, that's this triangle here, which has an area of 1, but we are going backwards, so it would actually be negative 1. And what we end up with is 0 over 0. So if we show that the initial limit is 0 over 0, we get a point. Okay? Because it's an indeterminate form. And anytime we have an indeterminate form, we're going to use L'Hopital's rule. All right, so if we go for L'Hopital's rule here, we're going to take the derivative of f, which is f prime. Derivative of 7 is nothing. Derivative of e to the 3x plus 6 is e to the 3x plus 6 times 3. So we'll put a 3 in here. And derivative of negative 1 is 0. If you did these derivatives correctly and had the limit as x approaches negative 2, that's L'Hopital's rule. They would give you a point for that. Now our job is to figure out what this equals. So f prime again is 3 plus g of x. So f prime of negative 2 would be 3 plus g of negative 2, which is 1. And then this is going to be 3 times e to the 0. So 3 times 1 is 3. We end up with 4/3. And if you had 4/3 as your final answer, you get a last point.